are responsible for chapter 6, 7, and 8. Chapter 6, it was about series. Chapter 7 is related to solving initial value problems using the class transform. And of course, we said that the variable should be, or the independent variable, it should be defined over the non-negative interval, real interval. And the last lecture, we were assigned to prepare the last part of section 7.3. Now, what we will do today is that we start with chapter 8 for more than one reason. The first reason is that on Thursday, maybe some of you is involved in the competition. So that in case you will not be able to attend this lecture, the lecture of Thursday, at least you know the first part of the chapter. Is any of you involved in the competition, the research competitions? But it's okay, we can continue this chapter. Now, if you look at the title of this chapter, it's system of linear first order differential equations. So what do we expect to learn? Let's go back to the first lecture that we learned. We introduced differential equations and linear differential equations. So what do you think? What do we mean by system of linear differential equations? No, that each of them is linear. And when we hear the word linear, we relate it to which course?
Yeah.
Linear algebra. And in linear algebra, any linear system, we were identifying it as what? What do we find for it? We are writing it in matrix. Matrix. So during this section, in order to understand all what we need now, basic derivative formulas and determinant. When we say determinant, it means that we have matrix. Our class learning outcome, our main objective is to demonstrate understanding about the basic concepts of linear algebra. So here we will not explain how to solve. We care about the basic concepts related to these ODE. As we did in the first lecture that we met, we introduced linear equation, what do you mean by solution, how do we identify the solution, how do we find the solution, the machine is part and these. Okay, but it doesn't mean that because it's true, we will not be asked about it in the examination. Now, what's the next step? The next step, we will learn how to solve. And the method to solve, as we said before, we'll learn to solve using eigenvalues and eigenvectors. So for those who are not taking right now linear algebra, please go back to the material for eigenvalues and eigenvectors. We don't care about diagonalization. All what we need only is eigenvalues. So we'll start by talking about linear system, the matrix for linear system. Of course, we are talking here about differential equation, solution vector. And why are we saying here solution vector and not just solution vector? How many equations do we have? More than one equation. So basically more than one unknown that we need to find, right? So maybe x and y, both of them we need to find. So we'll find x and y. X in terms of t, let's say, and y in terms of t. Now, of course, this is the method that we will learn today. We will learn hopefully in chapter 8 how to solve linear equation. It doesn't mean that it's the only method that's also we can apply masters. But in our syllabus, we are not responsible for the masters. Then we will discuss the initial value problems. We'll talk about fundamental set of solution, but this is logic. Because I don't want just to find a solution, we need to find all these solutions, okay? And then we'll talk about the general solution of non-homogeneous. Now, this lecture, you will feel like as if we went back to the first lecture that we met and we discussed all of these ones except matrices. We explained them for chapter 1. Okay. When we say linear systems, linear system differential equation, we are concerned here about the first order of thing. Okay, so if it's first order, what do we have? Derivative. So x1 prime is written in terms of x1, x2, till x5. Here x1, x2, and they are variables. The dependent variables, and the independent variable here is t. So we don't want to find t. What do we need to find? X1, x2, x3, and so on. And these A1T, A2T, they can be constant, is that they can be zero, or they can be any function and what? N-T. Similarly, X2 prime is written in this way. And if you look here, you are writing it with F1T, F2T, Fnt. This one they are given. Let's say I'm putting here T, here sine T, and here 2. They will be here. Okay, miss? If you want to write the form of the linear system, please write that again. Here we are concerned about which order linear system, first order. Okay? To finish this introduction, we will go again to the lecture that we prepared and discuss. Please. Those who finished writing, try to write it in matrix form. Just give it a try. Here, what can we put? A11, A12 till A1 and as what? Matrix, right? And the column factor, it will be X1, X2 till X. But we have a plus this one. Can I put this one as a vector again? We can put it. Try it. What do you put? Yeah, so continue this one. Where do the by something and complete the matrix. Try to write the system in matrix form. Okay, can we take these matrices? This matrix, I expect that all of you wrote it, right? And we have an extra column here, F1T, F2T, till Fnt, right? So something equal, before the equal, we will discuss it, but after the equal, it's this matrix times this vector plus this vector, right? We can try it. A11 times x1, A12 times x2 plus A1 times x2 and so on. Now here we have dx1, dx2 till dxn. Can you take the d outside? What did we get here, miss? Look at this one. Look at this form. Right? Right? Equal ax plus x. What do you think? What will happen if this x is equal to 0? If x equal to 0, what would we call the system? Homogeneous system. Okay? So this one, if x is equal to 0. We'll give examples. Now, when we will learn how to solve we will consider systems, linear systems, that they are two equations to unknown or three equations with three unknowns. Here I'm giving you the number of equations equal to the number of unknowns. Any idea what? What did we say? Which method creates eigenvalues, right? So if the number of equations is not equal to the number of unknowns, would we get square matrix? So we need square matrices in order to find their eigenvalues and eigenvectors.
Homogeneous system, the F going easy.
We will not put plus d or plus d squared and so on. Did you finish writing your ordinance? Done?
Yes.
Johnny, done?
Yes.
Let's set up. How many equations do we have? And how many unknowns? X and we have the x, y, dt. So the independent variable is t. It means that we need to find x of t and y of t. So any solution it will be of the form x, y, right? If you want to write this one in matrix form, this is a first one here. So here on this side, I will put the x prime, right? And here, what's the option matrix? 5, negative 7. And we will multiply it by 3. Is it homogeneous? Do I have plus at t? Okay. How do I know they are not supposed to tell us plus 0? But if I have here plus t, what should I add here? Plus t? C. So the first one, what can we consider it? Homogeneous. This is two equations with two unknowns. Now let's look at the second one. What's the difference between the second and the first? First, in terms of the equations, how many equations do we have? And how many unknowns? So the vector is x, y, z. We will write x prime equal. Now, if you look here, we have something. We have this one. So is it homogeneous?
No.
So do we have plus f? And we will take again the matrix again, A, the options of x, y, and z, and we'll multiply n by x. So here we wrote this one is non-homogeneous system. The difference between homogeneous and non-homogeneous, are you okay with that? Just the extract. That's what it involves them. So now we know the shape of the homogeneous and non-homogeneous linear system. The first thing that we need to learn, we have system. What do we need for this system? To look at it only, what do we need? Solve it. So we need solution for it, right? Before we learn how we can solve it, we will learn what's meant by solution. And if we have a factor, how can we identify whether it's a solution or not? Usually or logically, what do we mean by solution?
Substitute.
Substitute, we will get the identity or left equal to right. Okay. What I need from each of you to do is to construct your own we need two of them. For the same one, I want the homogeneous part and the non-homogeneous part as well. We need 4 variables. 4 independent variables means that I need x1, x2, x3, x4, and the independent variable is t. So we need a homogeneous one and a non-homogeneous one. Would like to come to the board and write his own system on the board.
I'm not sure if it's solved or not.
Yeah, so solve it.
Uh,
I will try to be this one private.
and direct 0.
Right, there is second one. So how many? We need also x2 private terms.
Yes. Yes. 3.
Okay. So this system that Johnny wrote on the board is linear and homogeneous. What's the matrix of that? So we write that prime equal AX, right? Can you continue writing A on the board? So you will write here D X1, X2, 3, 4 equal the matrix 5. Yeah. Okay. 3, 0, 0, 3. Here it doesn't mean that every linear system we are able to solve. Okay, we are talking about the linear systems that they have before x prime equal ax. Okay, where of course, and it should be linear or x prime equal ax plus that. So this one, the one that was written by Johnny, it's one homogeneous. If you want it not homogeneous, we can add here plus sine t, let's say. Here or here plus t, or we can add t to all of them. Okay. Do we have any question? Okay. What do we mean by convolution? If you are given a system and variables are x, y, or the variables are current and the capacitance. So I will, and they, of course, it's a system that contains the current and the capacitance. I will just say that the current is equal to this one. Does it make sense? I have two variables. I will return only the value of one variable. Why? Because they go together, right? So the current is in this way, and capacitance is equal to something. So I'm returning current equal, capacitance equal. So I'm returning one factors. Okay, miss? So here, the solution is of the form of one factor. How many variables do we have? So I will find the first variable equal to 1, the second, the third, and the fourth. Okay, miss? So if we go back to the example that Johnny constructed on the board, here a solution vector it should be one. What do we need to find? X1, X2, X3, X. If you follow only X1, that's incorrect. Okay. Now, how do we identify if we are given a vector? How can we say that this vector is a solution? What do we need to do? Substitute. What should we get? Left equal to right. Okay, miss? So please write what do we mean by a solution vector so that we can start by applying it. Please write the question x1 and x2 and write this equation. Do not copy the solution because you will find it. Just write the first part. Write x prime equal ax, x1 and x2. We need to verify that x1, x2 is a solution vector of this. Why do we have only x1, x2? What's the sign of the matrix? 2 by 2. So we have two variables only, x1 and x2. Think about the 6 examples. Okay. So what's on the left-hand side? Left-hand side. Right. Which is x1 prime, 2. So what do we need to find? x1 prime and x. Find x1 prime. Okay. First of all, we want to show that x1 prime is a solution. We need to show both of them that they are a solution. Okay. So the first thing, x1 prime, we need to show that is a solution. So what do we need next? We need to verify or check x1 prime is equal 1 3 by 3 and here times x. Here they are giving us two solutions, two factors, and we need to check if each of these factors is a solution. Okay, here I'm putting checking, but no need to put checking because they are saying to us verify. So what's the left-hand side? 1 prime. What's the derivative of x1? What's the derivative of e negative 2t? Minus 2. Okay, our derivative of negative e negative 2t. Negative 2, and already I have negative. It becomes positive. So here, what did we use this? A power, AE, derivative of and AE, AE80. Okay, so we found the left-hand side. Now, after the left-hand side, what should we find? The right. Please write it down, and if you finish writing, do the right hand.
What the 1 and minus 1?
Here we can write the factor either in this way or this way.
Even this one. So they multiply the minus 1.
Exactly. Now, what do we need to find? The right-hand side. What's the right-hand side? A times what was A and what was X? What was E negative E, negative E, negative 2T. And A, it was 1, 3, 1, 3, 5. How to multiply the two statements? Row by column. So this is the right-hand side here. Multiply them, what will we get this? E minus 2T
3.
minus 3, E minus 2T. And here we will get
5.
5 E minus 2T, which, what did we get? Okay, let's highlight our answer. And compare it to the left-hand side. What do you think? Is it equal to the left-hand side, Miss?
Yes.
So if the left-hand side equal to the right-hand side, what can we deduce about x1?
Solution.
So left-hand side so we can deduce that x1 is a solution.
So let's first take the one over there. Make sure that's it's
Yes, till now we don't know how to solve. We know to check. Next lecture, hopefully we'll learn how to solve. Yes, Maina?
You will click the
Your left-hand side. And this is your right-hand side. Are they equal? So it's a solution.
how do we check if x2 is a solution?
Yes. Okay, to make sure that everything is clear, each student check x2 is a solution or not. We wrote x2, right? Yes, x2 is equal to 3e6d, 5e6. Please check if x2 is a solution. on the left-hand side and the second one while you are checking. This would be the
18 equals 30 equals.
okay, yes. So we will find the derivative, we will get 18e60, and here we will get 30e60. Did we get all of us the left-hand side of this way, miss? Do the right-hand side now. Right-hand side is multiplying the matrix by a column matrix. Okay. Did we get the left-hand side equal right-hand side, miss? Who got other than Amr and Ahmed? Yes. The others? Okay, let's wait 2 couple of minutes. Okay. Did they get the Shah, did they get the left equal right? Okay. Shamus, you're still solving. This is excellent practice. And then okay, so now we know what to mean by solution. What if we have 3 equations with 3 unknowns? The solution would be of the form x1, x2, x3. Okay. Now, what do we mean by initial value problem for the linear system? We are given the linear system, but what we are given the solution at a certain value. X, it's given as something, okay? So usually when we say initial value problem, it will be given in this way, x prime equal matrix times x plus a function, it's non-homogeneous, subject to x at, this, it can be 0, it can be 1. That's an initial value that you are given. The solution, the function at this point is equal to a vector. This is what we mean by initial value, value. Who can give us an example of an initial value? Can you talk an example of an initial value problem? Let's put it as 2 equations. Okay. We need to construct our own initial value problem. Let's do it just as 2 equations that are unknowns, and I need a volunteer to come to the board and solve. Noor, you will write it on the board. Okay, try to do it on your notebook, and we can do it with the manual. Miss, is any of you involved in the research competition on Thursday? Would like to come to the board? No, did you finish your initial volume problem?
We got 6x minus 3 and x y. Y0 equals 4, y0 is 15.
Y0 and Y0. X0, you mean and Y0, right?
On y0.
No, it should be X0 and Y0. Okay, so we will write, we need X prime and Y, right? Or X1 prime and X2 prime equal. What do you want them? It doesn't mean that the system has to make sense. We are constructing our own example. At this moment, we don't care if it has a solution or, okay? So X prime is what you want here, 2X. And what do you want beside it? What do you want?
You
Green line. Do you want also to be non-homogeneous? Let's say T squared. Okay, the second equation, what do you want it to be?
2x5.
What?
2x5.
2x5. I don't have the right to put x5 linear. If I put x5, it will not be really linear system. And I cannot denote it as matrix, okay? So a system of differential equation, I can have x5. But here we are just concerned about linear. So I can put x. If you want to minus 2x, we will put it. What do you want also beside it?
5.
5. And what do you want this one? You want it empty, constant, or something in T? What do you prefer to have here?
Just say constant.
Constant. Okay, so minus 9. 9 minus. In this way, a system of two equations with two unknowns and it's linear. To be an initial value problem, if I'm writing x equal xy, where do you want the initial value to be?
x0.
Okay, x at 0. What do you want it at 0 to be?
1.
It means that x0, this one, it means that this is the first variable at 0, and this one is the second variable at 0. Is it necessary to take the initial value at 0? Of course not. We can take it at 1, at 2, at 0.5, any value that we want. Okay, miss? Any questions? If you want three equations with three unknowns, x naught, it will be how many values as a column? 3. Okay, listen. I got it. In differential equation, we can play with differential equations as we want, and we can create lots of equations. But at the very end, it's not that we are creating an equation and we are solving it. It's that we have a problem. This problem, the problem creates the equation. How we modeled it through a differential equation. Okay, so there is a problem, and we are modeling it through differential equation. We have a problem. What do we need to do for this problem? Check if it is solvable, right? Does it mean that every equation is solvable? Every differential equation will be solvable? No. We'll start now for the condition for an initial volume problem to be solvable. Look at it. Isn't it the same one as we set for the differential equations that they were not certain? Continuity. All what we need is the AT, everything in the matrix that you have, and by the way, just like we can have here 2t. So this one, it will be, we can have it as 2t, it's okay. Something in t. So everything in the matrix, it should be what? Continuous. What do we mean by continuous? Yes, the function exists and the limit exists. It means that it doesn't have problems. So if this one is true, then it's what? It has a unique solution. Let's go back to this one. Look at the matrix. What will be our matrix?
2t.
3 minus 2, 5. Do we have a problem in these entries of the matrix? They are continuous, right? And the f of t, what's f of t? Negative t squared, negative 9 pi. Do we have problems in it? The first one is a polynomial, and the second is also a polynomial, but we can say that is constant. So we don't have problem in that. So both of them are what? Continuous. So based on what we explained here, this one, does it have a unique solution or not? It has a unique solution. Okay, miss? So please put it as a rule. How do we identify it has a unique solution? And link it to the previous part, that this one, it has a unique solution. This, by the way, this one, it tells us it has a unique solution. But if suppose that it's not continuous, we cannot deduce it doesn't have. We need to check another method for it. Okay, miss? We're done with the initial volume problem and the uniqueness or existence of unique solution. This is very important because if you have a model and you already did it as a linear system, the model it as a linear system of differential equation, and of course we'll get an initial volume problem. If we have the continuity, then we can deduce that it has a solution, and the solution is unique. Now, how do we find the solution? We have lots of methods to find the solution. And in case none of our methods work, we can go always to numerical analysis. None of you took numerical analysis, right? When are you supposed to take it? It's not in your. You call it for numerical methods. Yeah, it's the same. Easy. It doesn't read like it's a method. Let's say one of the methods like Newton's method, finite separate method, just algorithm, and you will apply it using MATLAB. Also, MATLAB is easy.
No, it takes group semester.
Yeah, it's easy. It's an easy course. It doesn't need that background in mathematics. Let's look at the superposition principle. Also, this one, let's link it to the first chapter. If x1 and x2 are solutions, then the linear combination of it, any linear combination of it is what? Again, solution, right? So here we are saying if x1 and xk are set of solution vectors of the homogeneous system, then the linear combination, any linear combination of them is again a solution. This one, it makes sense, right? So let's apply this one for this exercise. This is a solution and this is a solution. What can we do? That C1 times this one plus C2 times this one is what? Is a solution. If you still remember, let's say if I'm telling you sine t and cosine t is a solution, then we said that C1 cosine t plus C2 sine t is a solution of the homogeneous differential equation. So here it's the same. Please write the superposition principle in order to apply that. Did you write this? That's an obvious one. Now, what I need from you, this one is how many equations? Three equations with three unknowns. Are we given the system as system or in major form? Okay, I want from you to write it as a system first. You are given the matrix form, write it as a system. You can write it x1, x2, x3, or xy. It doesn't matter. It doesn't mean that voltage see as I told you that if I'm working on current and voltage or current and resistance, I may call them I of t, b of t, r of t, c of t.
X1 here. How do I know if it's X1 or X2 or the what X1 2?
No, x is you would write it, you would choose your x as
I don't
x, y, z, or x1, x2, x3. This lecture is an introduction to linear system. And hopefully next lecture we will solve. But again, this lecture doesn't mean that we will not be examined. It's included in the final. How did we write it as a system? Fine equal x plus b, y prime is equal x plus y, and z prime is equal negative 2x negative z. Right, miss? Okay, so this is if we want to transform it as a system. Now, if we have an initial value problem, suppose that we have an initial value problem, this system, do we have a problem in it? So all the functions, they are constants and it's homogeneous. So it's what it has a unique solution. But now this one is not an initial value problem, okay, miss? We are given already two solutions for it, x1 and x2. You are given the solutions. We are not asking you to show that they are solutions. But if we ask them, and this one you can practice it at home, you will substitute left-hand side equal to the right-hand side. The exponential we know is derivative. The zero we know is derivative. It's constant. The derivative of the constant is zero again. Cosine t, the derivative of it is negative sine t, and sine t, the derivative of it is cosine t. And that's to our solution. It means that any linear combination of them is again what? Gamma solution. So I will multiply C1 times the first factor plus C2 times the second factor. Okay? Is it clear, miss? Let's go back to chapter 1. When we say that this is a solution and this is a solution, let's say I have the equation y double prime plus y equals 0. And I'm telling you that sine t is a solution, and 2 sine t is a solution, and 3 sine t is a solution, and pi times sine t is a solution. Do you care about these solutions? You care just about one of them, right? Why? Because all these solutions that I'm saying, sine t, 2 sine t, 3 sine t, negative 100 sine t, radical 2 times sine t, they are what? Dependent, right? So what do we care about solutions? When we give different solutions, we care about what? To be dependent or independent? Independent. So now, the next step, we need to talk about the linearly. When can we say that these solutions are dependent or independent on each other? Okay, miss? Now, logically, if we look at these two solutions, are they dependent? If we have two vectors, how do we determine whether they are dependent or not? Scalar multiple of each other. So these ones, they are independent on each other. If I told you 0, 2 times e power t, 0, then it will be what? Dependent. Okay, miss? Now, how do we determine the dependency and independency? As we took in linear algebra, this one, it should have what? Trivial solution only. Otherwise, if we have constants, not zeros, it's fine. This one, it means that they are what was linearly dependent. So it's the normal definition of the dependency and independency. But how will we check it? How did we use to check whether functions are dependent or independent in chapter 1, chapter 2, I think. Chapter 4. What did we find? Ranskin. It said that the Ranskin, if it's 0, then they are dependent, and if it's not 0, they are what? Independent. So what did we use? We used from linear algebra the determinant constant, right? Here we will do the same. Instead of going for the definition of it and proving that all CIs are zeros, what we will do is, you are given these vectors, you will find the Ranskin of it by writing them as column vectors. We don't need here in this Ranskin to find derivative. Just you will put the first vector as column, second vector as column, till we reach the last vector. You will evaluate the determinant. You know how to evaluate the determinant, miss?
Yes.
Okay. If the determinant is 0, then they are dependent. And if the determinant is not equal to 0, then they are what? Independent. Let's apply it. Here we are not asking you to show that there are solutions. You are given the two solutions. Already we showed that there are solutions, right? We need to show now that these solutions are independent. So this vector, we will put it here. And this vector that is here, we will put it here. And we will find the determinant. Let's recall the determinant of a 2 by 2 matrix. We have A, B, C, D. What the determinant of that? Okay, main diagonal minus the second diagonal. Okay, yes? So let's multiply. E power negative 2t times 5e6t, it will be what? 5e 40. Minus plus 3e 40 will get 8e 40. So what can we say about this one? Did we get the 0? We got it not 0, so is it dependent or independent? Now, there's an easier way from linear algebra to show that they are independent. These are two vectors only, right? Is any of them scalar multiple of the other? So they are independent. So either we use the Wronskian here, or what do we use? We use our information or our knowledge from linear algebra. Now, the question that we will ask, how many independent solutions we should have? Let's recall, if we have a second order differential equation or a first order differential equation, how many independent solutions should we get? Well, if it's second, 2, and if it's third, here also the same. And this one, what do we call it, miss? Do you still remember the fundamental set of solutions? So here we have also fundamental set of solutions. So we define what do we mean by linear system. We wrote it as, we know how from linear matrix form, from matrix form to linear system. We talked also about the matrix of linear system. We talked about the solution vector in which we substitute, we'll get left equal right. We talked about the initial value problem and the existence of unique solution. And the existence of unique solution is dependent on the continuity. And now we still have only the fundamental set of solutions, and we have the general solution of homogeneous. Fundamental set of solutions, already we started with it by considering linearly independent solution. So when we say linearly independent, and we have, let's say, 5 equations with 5 unknowns, I have 5 vectors. These 5 vectors to determine whether they are dependent or independent, or what we need to find is the Wronskian. Wronskian equal to 0, معين, it will be dependent or independent? Dependent because it's equal to 0, and it's not equal to 0. Let's say I got t squared minus 1 as w, then it's independent or dependent? Independent because we got a value or a function. Okay, miss? Okay. Now we still have to talk about the fundamental set of solutions, and then we'll discuss the non-homogeneous solution. So fundamental set of solutions, we are saying that x1, x2, and xn are linearly independent solutions. And linearly independent solutions here are given x prime equal to ax. And this one is n by n. Okay, so if I have two equations with 2 unknowns, how many independent solutions should I find? How many independent solutions should we find this? If it's 2 equations with 2 unknowns. So if it's n by n, it means that we should find n linearly independent solution. If we have these n linearly independent solutions, then we form them fundamental set of solutions. Okay? So here again, we are saying there exists a fundamental set of solutions for the homogeneous system on an empirical line. So every homogeneous linear system that we have x prime equal ax, it has a fundamental set of solutions. The general solution, if x1 till xn is a fundamental set of solutions, how do we write the general solution? It's linear combination of, okay, miss? So just let's explain it here. Here, the system is, the matrix is 2 by 2. We have two vector solutions, right? These two vectors are dependent or independent? Independent. So what can we deduce about C1x1 plus C2x2 is what? They are fundamental set of solutions, and C1x1 plus C2x2 is the general solution. Okay? If you want to take your notes, please take them, miss. We'll apply it for two questions. First question, we'll discuss it together, and second question, I will give you time to solve. This lecture is it's a copy of our first lecture, but the only difference is that there we have only one equation, one differential equation. Here we have simple differential equations. Let's go back again to this example. This is homogeneous. This is what? 2 by 2. These two equations, or these two solutions, they are independent, right? They are linearly independent. What's the number of them? 2. And the matrix is 2 by 2. What can we consider it? Fundamental set of solutions. How do we write the general solution? C1 times x1 plus C2 times x2. This is the general solution. Why? This is a fundamental set of solutions. Okay, miss? Is it clear? How do we show that it's fundamental set of solutions? The number matches with the size of the matrix, and the Wronskian is what? Not zero. Okay. Do another example, and you will do alone. And this crash. Okay, we have this one. How many equations do we have? 3 equations, 3 unknowns. How many vectors are we given as solutions? 3. The first step, miss, what I need from you to do is show that we form a fundamental set of solutions and the second part, right, general solution. So we start with an each two together, and during this time, I will take that list. Let's solve it and first during this time, I will take that one. Are we solving it, Miss? كبير عبد العزيز الشمسي عبد الرحمن بن مؤيد لؤي السلطان عبد الله المنصوري إرشاد السير إسماعيل أبو سيد عمر السير جوني علي and Maria Bisnotti. So we need to find their answer, right? Right, find the determinants and let's share our answers with colleagues.
I can deduce that they're not built with a computer.
No, because if you have three factors, you put multiple either way. Or we have three factors, you put over these two. So who got the value for the determinant? What did you get? 1. Let's try to do it again. What is the determinant as E power T? What did you get?
It's 40.
E power T. Who other than Tony got E power T? Perfect. So others? Okay, let's wait a little bit. How do we find the permanent list? Plus, minus, plus. We have this one 0, so I will not consider it. You will start with this one, cosine t into covering et times this one minus 0. Then plus sine t, this one is already 0 minus this value. We got e power t. It's not 0. What can we say about this? Linearly independent. Their number is 3 and the system is 3 by 3. It means that they form fundamental set of solution. How do we write the general solution? C1 times the first vector plus C2 times the second vector plus C3 times the third vector. Of course, C1, C2, C3, they are constants. Do we have any questions, guys? We're done now with the fundamental set of solutions and general solution. Then we have one idea, which is the solution of a non-homogeneous system. course, when we're evaluating the Ralston, X1 will be the first column, X2 the second column, X3 the third column. So let's go to back to our outline, the fundamental set of solutions. We are done with it. Now we need to talk about general solution of non-homogeneous. We know what's meant by non-homogeneous, right? It's on page 4. X prime will be at plus at. And this part that is here is the homogeneous part, right? And the non-homogeneous part is the at. The at can be function in T, like t squared sine t, or also constants, which we can consider them as functions in T as well. Now, what do you expect? Let's go back to if we have a non-homogeneous differential equation. How did you use to solve non-homogeneous differential equation? What do we solve first? The homogeneous, we find the general solution, right? With that, what do we need to find? What do we call the other solution? Particular solution. Then, the last step, we will write the solution as general plus part. What do you expect here to have? Also, we should have particular solution. The solution for the homogeneous one is the general solution that we know it for the homogeneous one, C1x1 plus C2x2 plus. We will add it to particular solution. This particular solution, does it contain constants? Doesn't contain constants. It's a function. Okay, but here our particular solution, it will not be a function, it will be vector containing functions. It means that it doesn't contain constants. Okay, miss? Okay. So, general solution of the non-homogeneous one. The first step, we need to find the solution of the homogeneous, which we call it as XT or H. So this is solution, the general solution of the homogeneous, the associated homogeneous. Then what do we need to find? A particular solution, which is XP. And then we will write X equal XP plus X. Okay, miss? Or XH, we write it. P is a particular solution and XP is the general solution. This one that is here. Particular solution. And this one is solution for the homogeneous system. Give an example, apply it, and then we'll choose some exercises to solve together, and we'll talk about the next steps. This will be next section. Because we start by the other ones that I can first. Okay, it's very important because the future lecture will be dependent on. Ali, who took linear algebra before, else who took linear algebra before and is not taking it now. All of us are taking linear algebra now. Now, in all sections that you are in, you reach the eigenvalues and eigenvectors, right? Yes, Miss Sultan, are you taking it now? Or
I took it a long time ago.
Okay, Miss, just remind me to share with you some recordings about it, or you can go to the recording if you want to. Any question? Let's look at this one. This one is non-homogeneous system, right? Why isn't it non-homogeneous? What do we have? Plus a function, plus a vector, right? We are given the particular solution. So here we did not learn how to find the particular solution. The particular solution is given. Plus, and we can verify it, okay? We can just substitute it, and it would be left-hand side equal right-hand side. And the solution of this one, already we proved in the previous part, right?
Yes.
How do we write now the general solution? We will just combine them together. So x equal xh plus x, and this will be our final answer. Is it clear, miss? So just we are adding.
Later on to get the possible solution.
During this section, though. During this section, even we did not learn how to find the general solution. Okay. Do we have any questions? You know how to prove that this is a particular solution, right? We'll substitute, find xp prime, substitute it here, add it here, and you will get left-hand side equal right-hand side. Okay, miss? Any questions? Okay, let's go back to our outline. If you try to prove it. Ahmed, done proof report? Okay, so introduce linear systems that they are of the form x prime equal ax plus f. If f equals 0, we will get homogeneous. If f is not 0, we will get it as non-homogeneous. And of course, when we are writing it in this way, it means that it's a matrix of linear system. Then we talked about the solution vector, which is substituting it, what will we get to ayat? Left equal, right. Then we talked about initial value problems, and one of the conditions for the halving solution is existing and unique. This is the independent, the unique, and the uniqueness. It should be one. Continuity of the F, and once we have in the matrix A, all inference coming. Then we talk about fundamental set of solutions, and their fundamental set of solutions. What should we have? Linearly independency, and we prove it using the Roskin model. And the last week we talked about the general solution of non-homogeneous, which is the solution of the homogeneous part plus the particular solution. Okay, and any particular solution, do we put constants? So particular solutions are free of constants. Now, what do we need to choose random exercises from here? Just to make sure that we understood the material. So I need to rewrite this one at matrix form. Yes, miss? Yeah, I will zoom it. So we'll write this one in matrix form. In this way. Is it 5 now, miss? And we need also to write this one as a system. So this one transformed from system to matrix form, this one from matrix form to system. And we need to show that this one is a solution. When we do these ones, These are practiced on the first 3 points in our lecture outline. Should I zoom more?
Yes, please.
Did you write this one, Matt?
Yes.
So part 1, did you face any problem in that? After what did we write the left-hand side as the first exercise? What did we write the left-hand side as at the first exercise? We said that this one we would write it as x prime equal ax. So x prime is what?
So,
D by dt x, y, and z, right? And a, 3 or minus 3?
3, 4, minus 9,
Okay,
minus 6, minus 1, 0.
okay.
4, 3.
Did all of us get it as Abdurrahman's? Is it homogeneous or non-homogeneous? Now the second one we need to write it as systems. So here what will we get? X prime y prime equal 3x minus 7y, and here x plus y. And what do we need to add to it? 4 sine t, and here plus t minus 4 into e 40. We'll have to give up the first equation. What did we get the first equation as? So x prime is equal to what in exercise number 10? We get it, Ahmad. X prime equal to what in exercise number 10?
3x.
Yes,
Minus 7y.
yes.
That's equal to t plus t.
T minus 4 e 40. Then all of us get this one as a first. Okay, the second one, Shamus, it will be what? Y prime equal x plus y plus 8 times sine t plus 2t plus 1 into 4t. Did we get it? This one is it homogeneous or non-homogeneous, Miss? That's when we are verifying a solution. Everything that is outside the vector we're going to. So this one I will send it to. And then I will find it. Okay, Miss? Please start with any questions regarding the previous exercises, Miss?
Dr. Madeleine, the unit 7.8, the unit section that we did.
Yeah, we will. I want to create that. Some of you are involved in the solution first day, so you will not be able to advance And I prefer always that the first lecture that we introduce a chapter on fuel. Because of that, I swap.
This will be
No, I will continue this one because none of you is involved. If some of you are involved, I will do the others. But as I asked you, no one is involved. And none of you is a volunteer, right? You're not aware of the Okay. So we're done with this section, which is an introduction, but it doesn't mean that as an introduction, you will not be asking about it in the exam. We'll have questions from the exam. What are the next steps? Hopefully next lecture, our aim will be, instead of proving that it's a solution, substituting, what do we need to do? Find the solution. And we start with the homogeneous one. The method that we will use is easy, very easy, because we are connecting it to linear algebra. And again, anything that we connect to linear algebra, it means that it's very easy. Okay, you are connecting it to matrix field, whether it be determinant, eigenvalues, eigenvectors. So it will be depending on eigenvalues and eigenvectors. But the thing that we did not take in differential and linear algebra, not because I did not cover it, because it's not, we are not responsible to give it numbers. The complex eigenvalues, complex eigenvectors. So I will start first with the real part, and next week we'll consider the points. Okay, miss? Do we have any questions? Okay, miss, have a great day, and see you inshallah on Thursday. I've already shared the annotation on Teams. Well, see you inshallah.